All right, so we're going to continue our look into Introduction to Exponential Functions. Looking at this question, it says, in a biology lab, 500 bacteria reproduce by splitting. Every hour on the hour, each bacterium splits into 2 bacteria. So just think about that for a second. Every hour on the hour, every single one splits into 2. So again, what is that saying? It says if I have 1 bacteria, right? The next hour, this 1 is going to split into 2. So instead of me having 1, I'm not going to have what? 2 of them. These 2 are going to split, each of them are going to split into 2. So the first one's going to have 2. The second one's also going to have 2. So this is going to be a total of 4. So it's going to split again and so forth and so forth. So what's happening every single time? How am I going from 1 to 2 to 4, etc., etc.? So if each of these 4 split, so I have 4 different ones, each of them split into 2. So this one I'll have 2, this one I have 2, this one I have 2, this one I have 2. I have 1, 2, 3, 4, 5, 6, 7, 8. All right, so again, instead of me drawing that out every single time, what is happening every single time for me to get the next number? I'm doubling it or multiplying it by 2. That's what it means. So if I start off with 0, okay, the number of bacteria when I start at 0 hours, no time has passed, it's not 1, but it's 500. On hour 1, on the hour, every hour, it's going to split into 2. So each of these 500 is going to split into 2, making them how many now? 1,000. Okay, so again, it's just doubling every single time. Then the 1,000 is going to, each of those 1,000 is going to split into 2, making them twice as many. So that's going to be 2,000. On hour 3, 2,000 of them are going to split into 2. So it's going to be twice as many. So it's going to be 4,000. On hour 6, so be careful. So this goes from 3 to 6, right? So we are skipping 4 and 5. Now we can do this manually. So we can say 4,000, double 4,000 is 8, double 8,000 is 16, double 16,000 is 32,000. But what if this number was really, really, really big? That's what we have to find a general equation that works for all values. Okay, so we'll come back to that in a second. We're just going to complete the graph and then write the equation. So let's go ahead and plot this. So in hour 0, I should have 500. So these are hours on the bottom. So in case you don't have that, so these are hours on the bottom. At hour 0, I should have 500. So if you look at that, this is 1,000, half of it, so half is here, right? That's going to be 500. So half of 1,000 is 500. So at hour 0, that's where I'm going to start. Then at hour 1, 1,000, I'm just going to double every time. Okay, so it goes 500. Then at hour 1, I'm going to double to 1,000. Hour 2, 1,000 is going to double to 2,000. Hour 3, 2,000 is going to double to what? 4,000. At hour 4, 4,000 is going to double to 8,000. And you can see we're exponentially growing. And again, what is an exponential function? It's something that starts off very kind of gradually, but then quickly increases. So it starts off real slow. So it starts off, you see, slowly increasing, but then all of a sudden, boom, it's increasing a lot. All right, that's an exponential function. And we can have, this is again, this one is a growth. And how do I know it's growth? Because it's increasing. If it was decreasing the other way around, that would be decay. All right, so now let's write out this equation. So if you remember from the previous video, there is a formula for an exponential function that we just need to go ahead and find. And we can see it right here. Exponential function formulas is y equals abx. Unfortunately, they don't tell you what y equals abx is. You have to remember it. In other words, you have to practice it so much that you live it. So I'm just going to write it out again. All right, so we have our equation in general is y equals a parentheses b and then x. And you'll understand the importance of this parentheses a little bit later on. All right, remind me again, sometimes, so I mentioned in the last video, and I'm going to put this in a different color. I'll just keep mentioning it because at some point we are going to switch off. So I'm going to put this in a different color. We do have a C here sometimes, but most of the time, and I'm going to explain what C is in this video actually. Most of the time, there's no number here. And if there's no number here, C is equal to 0. Very important that you remember that. All right, so let's go ahead and label each thing. So my y-intercept, all right, my y-intercept is A plus C. All right, my y-intercept is A plus C. And if there's nothing there, it's 0, which means then it's just A. My B is how it is growing / decaying. And I'm going to go ahead and mention it in this video. It's growing if it's bigger than 1. It's decaying if it's between 0 and 1. So it's between 0 and 1, but not 1. All right. It's growing if it's greater than 1. It's decaying if it's between 0 and 1. If it's right at 1, it's not growing and it's not decaying. Okay, so I'll go ahead and add some additional notes. All right, so I am going to tell you what C is. C is called your isotope. And I know I am mispronouncing that and misspelling it. So please Google how to spell and pronounce that. So isotope. All right, so let's go ahead. And now that we know in general what our formulas mean, I know that my isotope is my C. And if you look at this, okay, and I'm going to prove this later, my isotope means it's where it gets approaches but never touches. And with these kind of questions, you can see it approaches 0 but never touches 0, which is why I'm saying most of the time C is 0, but we will get to a point where C is not 0. So isotope is 0. So what is your y-intercept? If I'm writing my equation, we talked about this in the last video, you can tell me what my y-intercept is from my table or from my graph. So we'll start with the graph because that's easy. What is a y-intercept? Where I cross the y-axis. And where does it cross the y-axis? What number? At 500. Okay, so my y-intercept is 500. So I have y equals 500. And again, how do I get that if I'm given a table? Let's go look at where 500 is. Where x is equal to what number? 0. If the table doesn't start at 0, but it starts at 1,000, you just have to go back 1. Or if it starts at 2, you got to go back 2 to get to that number. All right, so y-intercept is 500 either from a table or from a graph. How is it growing? So that means you're looking at by factor, by multiplication, how am I changing every single time? So how do I go from 500 to 1,000? I multiply by 2. How do I go from 1,000 to 2,000? I multiply by 2. So each time I am multiplying by 2. So my growth is 2. And then x is, and I forget to write this one in all the time, that is time. So the time it takes. So x is my time. All right, so they want you to write this in general. This is what you're writing. So t is going to be 500 parentheses 2, but instead of using x because they've called time t, I'm going to use t. Okay, so that's how you write an equation from either a table or from a graph. Now let's answer some questions again. Nothing new that you haven't seen before. What is the meaning of t equals 0 in this scenario? So remember, with the problems like this, you just have to use what the question is saying. So it's a biology lab. 500 bacteria is being reproduced every hour on the arrow. Okay, so what does t equals 0 mean? So you look at where t is equal to 0, and you're using these words right here. Pause the video and see if you can write it out. All right, so you know there's so many ways you can write this, right? So I can say what's happening when t is equal to 0. At 0 hours, the number of bacteria is 500. I can say when in the biology lab, when I start, I start with 500 bacteria. I can say before any time has passed, I have 500 bacteria. I mean, there's so many different ways that you can write it. So go ahead and share yours with me. All right, so I'm going to write in my bio, I guess in a, not my, it's not mine, right? So in a bio lab, they start with 500 bacteria. Again, 1,000 ways you can say that. You can say before any time has started, we have 500 bacteria. Just make sure that you're using the words that they give you in the context problem. All right, number 8, how can you find the value in the table and in your equation? All right, how do you find this value? Sorry, what does it mean of t equals 0? How do you find this value in the table? So let's answer that. I can find my, and I'm also going to say this is my y-intercept. How can I find my y-intercept from the table? Where x is equal to 0. How do I find it in the equation? Where it crosses the y-axis, because it is the y-intercept. How do I find my start? Where x equals 0, where it crosses the y-axis. All right, in a different biology lab. Okay, so that's the one I'm doing. So now you're going to do the rest of it. This is the question that you're doing right underneath it. In a different biolab, a population of a single cell parasite also reproduces hourly. The equation is given to you. So this time I give you the equation. Go ahead and fill out the graph and everything else underneath it. Let's practice.